Hi there, and welcome to the lesson which is on applications of vectors. So we've kind of covered the basics of vectors now. We're moving on to how to apply them. Okay, so let's move on to a little warm-up as well on some of the basics of vectors again. So let's practice finding the angle between the vectors v equals 2i minus 6j minus 3k and w equals 5i plus 2j plus 7k. So remember, you've got your formula booklet with the angle formula in there. Oops, not that one. Here it is. So the formula booklet, it's topic 4 vectors. So you've got the formula for finding the angle, and remember they remind you how to find the dot product, and also they give you the rearranged version for finding the angle as well. So you can go straight to using this version, and if anything you can kind of just pop the dot product straight on the top. So let's do that as well. Oops, here we go. So again, this was from the exam formula booklet, but with the dot product kind of popped in on there. So you've got to work out the dot product. If it helps, write it out as a column vector. Write this one out as 2, -6, -3. Write this one out as 5, 2, and 7. Then you do that times that, plus that times that, plus that times that, and so on. And then work out the, remember these are the magnitudes, so Pythagoras in 3D we use for those. So we've got 2 times 5 plus -6 times 2 plus -3 times 7 as the numerator here. And then you work out what those are. 10. So 10 minus 12 minus 21. 10 minus 12 is -2. -2 minus 21 is whatever you think it is. I'll leave that for you to do. Then you do the magnitude of this one. So you've got 2 squared plus -6 squared plus -3 squared in the square root. And then for the other vector, you've got 5 squared plus 2 squared plus 7 squared in the square root. These get multiplied together. Remember, this is cos theta, so then we're going to need to cos minus 1 the answer. So this plus this plus this gives you root 49. What is root 49 equal to? That's right, it's equal to 7. And this one is root 78. So 7 root 78. So you've got -23 on the top, 7 root 78 on the bottom. And that's what cos theta equals. But we need to work out what theta equals. So of course you would do cos minus 1 of this. Grab out your calculators to practice doing that. Check your mode. Are you in degrees or radians? Yes, you're in degrees. Fab. And then go second cos. To make cos minus 1. Alpha y equals if you want a nice fraction. Putting in -23. Over here 7 root 78. And arrow out of there. Practice using your calculator a lot. You want to be really good at using your calculator. And then write out your unrounded answer, and then you can round your answer. So, oops. Write out your unrounded answer, and then, so as I said, write your unrounded answer though, and then your rounded answer. This one is a 3 sig fig answer that I've given. Here's another warm-up. Find a vector equation. So remember, what is a vector equation? Oh my goodness, have I forgotten? Have a look in your formula booklet. Vector equation of a line. So r equals, remember that's just the position vector of a point on the line. This is just the scalar, and this is the direction vector. So find a vector equation for the perpendicular bisector. Remember what perpendicular bisector was from the previous lesson, of the points A, which is 2 and -6, and B, which is 8 and -4. So in case you forgot, a perpendicular bisector is a line which cuts through the midpoint of a line and at 90 degrees. So bisects means to cut in half. So first of all, you might want to find the midpoint of the two coordinates. Remember from coordinate geometry, midpoint formula? Again, that's in your formula booklet too. So x1 plus x2 over 2, y1 plus y2 over 2. Is it in the formula booklet there? No, it's in a separate part to vectors. I think it's in the geometry section. So here's your x1, y1. You might want to label this x1, y1, label this x2, y2. So average of these two gives you 5. Average of these two gives you -5. That's basically what the midpoint is doing. So you've got the coordinates of the midpoint. So, remember from the vector equation of a line, we need a point on the line. So that midpoint provides the point on the line. So this needs to be the position vector of that point on the line. So the position vector would be 5, -5 as a column vector. So that's our point on the line. The general form of a vector equation, again, is this. This is the version that I kind of had in my earlier slides. This is the version in the formula booklet. So we've got point on the line, the position vector of a point on the line, and the direction vector. And this is the scalar. That's a general form of the vector equation, where P is the position vector of a point and Q minus P is the direction vector. You already can see that P, we've got the point on the line at the midpoint, so that's the position vector of the point on the line, so we've already got this one catered for. Now we just need to find a vector that's perpendicular to AB. So we need to find a vector that is perpendicular because it's a perpendicular bisector. So this is the line AB, this is its midpoint, so for it to be perpendicular it's got to be at right angles to the line AB. So how could we do that? So you can work out first of all what is vector AB. So to work out vector AB, so you can write out the position vector of B minus the position vector of A. So the position vector of B would be 8, -4, minus the position vector of A, which would be 2, -6. So AB, and going from A to B, that's how you work it out. But the position vector of B minus the position vector of A gives you the vector AB. So 6, 2 is the vector as you go from point A to point B. You go obviously across 6 and up 2, which you can also see from here too. It's pretty obvious you go across 6, and from -4 you go up 2 to get to -6. No, from -6 you go up 2 to get to -4. So go across 6, up 2. That's why we have this. So use the fact that the scalar product is equal to 0 to find the mystery vector. So remember, this is if two vectors are perpendicular, their dot product or scalar product is equal to 0. That's a very important thing to remember. So we can try to think, okay, 6 times what plus 2 times what could potentially get you an answer of 0. So try to think logically what would make sense. So basically the direction vector, if you put dot product it with this one, you've got to get an answer of 0. So you could think, oops, so you could be thinking like, you know, okay, so therefore 6x plus 2y must equal 0. That's one way of looking at it. So therefore 6x could be equal to 2y. This is one way of working it out. If you're having trouble kind of logically working out, you can use this method. Here's our mystery direction vector that we need to work out for this. This is the one that we know is perpendicular to it. The dot product must be 6x, that times that plus that times that, so 6x plus 2y must equal 0. So therefore, rearranging this, 6x must equal -2y, and so on. And therefore, you can...
I'm talking to you.
To make it even more complicated, we could go, okay, if you took x and rearranged it this way, so take x and divide by y, and you can take -2 and divide by 6, so basically divide both sides by y, and then divide both sides by 6, you can kind of get this little setup. And -2 over 6 simplifies to -1/3, so you can think of x, y as being -1 and 1/3 and 3. So if you're having doubts that you did this correctly, how could you test that it is actually perpendicular to this vector? You could find the dot product of it to just double check, does it equal 0? 6 times -1 plus 2 times 3. 6 times -1 is -6. 2 times 3 is 6. -6 plus 6 is 0. So you know for sure you've got the right answer. So you can kind of look at it and just try to work out, okay, that times that plus that times that equals 0, so what's going to work? This is one that works. And you've tested it out by testing the dot product equals 0. So you've got your point on the line, the position vector of a point on the line, and you've got your direction vector. So you just sub it into the thingamajiggy. So the vector equation for the perpendicular bisector is 5, -5. Remember, that's the position vector of the midpoint, using the midpoint. And this is the direction vector. So that's what you can do when you're asked to find a perpendicular bisector and the vector equation of it. pretty complicated. Another one, find a unit vector, because we've done a lot in the past, so that's why we're going to do quite a few warm-ups. So find a unit vector which is perpendicular to both of these vectors. So remember a unit vector? A unit vector by definition has a magnitude of what? Back to an earlier lesson. That's right, a unit vector has a magnitude of 1 by definition. And it has to be perpendicular to both of these ones. So what on earth could you do? Well, you could, what did I do? Okay, so I basically wrote them as, first of all, column vectors. So 2, -3, -2, and also 1, 2, and 3, write them as column vectors. And for them to be perpendicular, so a unit vector, and so it's got to be perpendicular to this one, and it's also got to be perpendicular to this one. So unit vector is perpendicular to both that one and that one. So you can come up with two equations, because this is the mystery vector that we're trying to work out. And we know that if it's perpendicular to this one, then its dot product must equal 0. Plus if it's perpendicular to this one, then its dot product must equal 0 too. So we can come up with two sets of equations, because that times that plus that times that plus that times that equals 0. And that times that plus that times that plus that times that equals 0. So let's come up with two equations. So we've got 2x minus 3y minus 2z equals 0, equation 1, and 1x plus 2y plus 3z equals 0 is equation 2. So we can use simultaneous equations. If you do simultaneous equations, we're going to try to eliminate something. So we could eliminate x if we do equation 1 minus 2 times equation 2. Would at least eliminate x. So I've got equation 1 minus 2 times equation 2. Don't forget it's not just 2x minus 2x, it's minus 3y minus 4y minus 2z minus 6z. So that's why I popped the bracket around there, because sometimes people forget to do that. You don't need the bracket, but you're meant to think like there is a bracket there. So put the bracket there if it helps. So we're doing equation 1 minus 2 times this. So the reason why I've got 2, 4 and 6 there is because I've doubled equation 2. And then 2x minus 2x is 0. Negative 3y minus 4y is negative 7y. Negative 2z minus 6z is negative 8z, 0. So we've got, so therefore you can rearrange this. So therefore negative 7y equals 8z and so on. So we've got an equation there. So a perpendicular vector is, oh sorry, just flipping back to here, I've just realised we've still got to do this part here. So, so negative 7y minus 8z equals 0. So what you could do is, okay, so negative 7y equals 8z, so that's what we've got going on here. So you could, similar, like on the similar slide, you could do y divided by z equals 8 divided by 7. So you can say, okay, y could be 8 and z could be negative 7. And now substitute y and z into equation 2 to find x, for example. So sub in y is 8, z is negative 7 into here, and solve for x. You end up getting x equals 5. So we've got our three answers here. You see we've done x plus 16, sorry, just 1 second. You might have noticed I just paused and fixed up a little boo-boo that was there. So yeah, so you sub in, this was fine, it was this part that was wrong, and therefore here and here. Okay, so fixing that up, plus I also forgot to fix it up down there, so just 1 second. Okay, this is exhausting, fixing up these mistakes. Okay, so now this is good. So as I said, so we rearrange this, we've subbed in y is 8, z is negative 7. So we've got x plus 16 minus 21. That was the wrong way around before. So 0 plus 16 minus 21 is negative 5. So we've got 8, negative 7, negative 5. So x, y, z. So the perpendicular vector is negative 5i plus 8j minus 7k using those three numbers. So beforehand on the slide by accident I had positive 5. So now find a unit vector, because it said find a unit vector. So remember, a unit vector must have a magnitude of 1. The current so you've got to work out what is the current magnitude of this one. Current magnitude of this one, use Pythagoras in 3D. So it's -5 squared plus 8 squared plus -7 squared, gives you 25 plus 64 plus 49, gives you the square root of 138. So how can you turn the magnitude into 1? You could divide it by square root of 138, because square root of 138 over square root of 138 is just 1. So what you can do is multiply each of these by 1 over root 138. So this is a quick way of doing it. You can just do 1 over root 38 brackets, put the other vector in there. Alternatively, you could have also written it as -5 over root 38i plus 8 over root 38j minus 7 over root 138, sorry, not 38, root 138k is the other way to do it. So it now has a magnitude of 1. If you worked out the magnitude of those ones, you can verify that for sure it does end up equaling 1 using the Pythagoras in 3D formula. Rightio, now finally moving on from that one. Let's go on to vectors in real life situations. So some common examples of vectors in real life situations. If you do physics, you probably use them a lot of physics for like forces and things like that. What are some other ones though? You've got airplanes, are quite common, movement of boats around the ocean, because it's got direction and speed and all that kind of thing. Cars, movement of cars, tractors, scooters, helicopters. Movement of a particle as well, like particles used a lot in physics, and also velocity equations, that kind of thing. The position of something is often represented by a position vector. So remember, on my earlier slides, I have a vector equation. So we've got a point on the vector, the position vector of a point on the line, plus t, which is a scalar, and q minus p is the direction vector. Remember in your formula booklet, that's given to you in that form. Here's the position vector of a point on the line, here's the scalar quantity, here's the direction vector. Okay, so the position of something is often represented by a position vector. So the direction vector is often called the velocity vector. So in these real life applications, the position is often used, the position of the thing, like the boat or whatever, is quite often used to find the p vector, and the direction vector is often used using velocity, and t, common application of t is time. So you probably see that come up a fair bit. So we can find the speed by finding the magnitude of the velocity vector. So you can find the speed by finding the magnitude, because speed is defined, it's a scalar quantity, so it has a magnitude only, not a direction. So if you find the magnitude of the velocity vector, it'll give you the speed. Points of collision is a common application, like where will a scooter crash into a helicopter and so on, that kind of thing. So points of collision can be found by setting two position vectors equal to each other, position vectors equal to each other and solving, not direction vectors, two position vectors equal to each other and solving. Let's do this application. I've got a tractor this time. A tractor is moving across a field at 10 kilometers per hour on a bearing of 150 degrees. So by that bearing of 150 degrees, assuming from north, you rotate 150 degrees clockwise. Express its velocity as a column vector. Holy moly, what on earth do we do here? So we've kind of got north, so remember 150 degrees, so from north, rotate clockwise 150 degrees, and because it's got a speed of 10, that means the length, the magnitude of the vector is 10. So it's going in this direction. So if that's 150 degrees, this one here must be 30, because that's 180 degrees in a straight line. So you've got a bit of a thing going on there. The diagram illustrates the vector. The horizontal and the vertical components are here, like you've got your I and your j. Horizontal and vertical components of the vector can be obtained using trigonometry. Because we can use SOHCAHTOA, we can use this right angle triangle. We know the length of this one, so we know the angle there, so we can use sine, cos and tan, because it's a right angle trig kind of problem, to find the vertical component. Vertical component is the adjacent side to 30, so you're going to use cos to find the vertical component. To find the horizontal component, you're going to use sine, because you've got opposite and hypotenuse. So the horizontal component is represented by the length of OA, which is the same thing as the one down here. So OA, you're going to be using sine theta equals opposite over hypotenuse. So sine 30 equals x over 10. Sine 30 equals x over 10. Rearranging that, x equals 10 sine 30. So 10 sine 30. Remember what sine 30 equals using your, if you could do this one non-calculator because you know the special triangles, the 30-60 degree triangle. So sine of 30 is going to end up equaling half if you use your special triangles, and 10 sine 30 therefore would be 5. Then you can also work out. So the vertical component is represented by the negative of OB because it's kind of going downwards in this case, because to go from here to here, you're going across, so it's a positive x and it'll be a negative y. So just work out what this length is using trigonometry, and then just remember that because it's a vector, it's got direction and it's going downwards, so it'll be negative. So cos of 30, so remember, so you can say cos of 30 equals adjacent over hypotenuse, cos of 30 equals y over 10, so y equals 10 cos 30. So y equals 10 cos 30. And remember, cos 30 is root 3 over 1, using your 30-60 degree triangle. Hang on, just 1 second. Oh, that's right, it's root 3 over 2. So what am I talking about? Just reminding you what the special triangle was. So cos of 30 would be the adjacent over the hypotenuse. So just reminding you of your 60-60, 30 degree, 90 degree triangle, 1, 2, root 3. So that's how sine of 30 is 1/2, cos of 30 is root 3 over 2. So plugging that back into here. So 10 times root 3 over 2 gives you 5 root 3, because 10 over 2 is 5. So that's how we've got that one. And so remember, it will be the column vector would be 5 over negative 5 root 3. Because in going from here to here, you're going across by 5 and down by 5 root 3. That's why this one has to be a negative. So notice that the negative is important as it represents the direction of the vector south, whereas this one was going east and then south. Let's do another application question. So this time it's a boaty one. A pleasure boat leaves a harbour and its position xy relative to the harbour at time t hours is given by the vector. So what it is, it's position xy relative to the harbour at time t is given by this vector. Find the speed of the boat, the position xy, so first of all let's just do A. So the speed of the boat, and then we'll deal with the rest later. The speed of the boat is given, as we said on an earlier one, by the magnitude of the vector, magnitude of the direction vector. So remember, this is the direction vector because it's got the scalar multiplied by it. So the direction vector is 10, and remember, as we said, the speed of the direction vector, the speed is the magnitude of the direction vector. So use Pythagoras with the direction vector, you get square root of 10 squared plus 7 squared, square root of 149. So the speed of the boat is square root of 149. Do they even have units? Whatever. You don't need to have units at this point then. And then we're moving on to the next question. So and we'll do that on the next page, I'll just read over it. The position xy of a cargo ship at time t hours is given by this vector. So notice this one has a position, it's got like, it's in the form of, it's in the form of this. So is the other one, it's just that you didn't have, like this was 0. So point A in this case was 0. So this one, its position is 0 basically. This one would be located at the origin, and that's the direction vector. This one is the position, the point P, sorry, on the line. The position of the cargo ship at time is given by this vector. So this is the vector equation, that's the vector equation for the pleasure boat, this is the vector equation for the cargo ship. So B, find the distance of the cargo ship from the harbour when the pleasure boat starts its journey. So you might be able to look at that and see that already. So I'll go on to the next slide because that's where we deal with this question. Find the distance of the cargo ship from the harbour when the pleasure boat starts its journey. So basically, just sub time is 0 into the vector equation. Sub time is 0 into here, this one's a goner. And so you're basically left with, pleasure boat starts its journey at time 0. When time equals 0, the cargo ship position is given by this. So, therefore, the distance of the cargo ship from the harbour at t equals 0 is given by the magnitude of this vector. So the distance of the cargo ship from the harbour when the pleasure boat starts its journey is given by the magnitude of the position vector. So 12 squared plus 12 squared equals 12 root 2, because 12 squared plus 12 squared is 144 times 2, 288, and this one is a multiple of 4. This one is a multiple of 4. It's also a multiple of 144, actually a higher square number. So this is a multiple of 144, and so it simplifies to 12 root 2. So that is the distance of the cargo ship from the harbour when the pleasure boat starts its journey. So remember, we subbed in t is 0 at time 0. This is a goner then. Just work out the magnitude of that. If both the pleasure boat and the cargo ship continued on the same courses, after what period of time would they collide? So as I said, collisions are a big application of vectors. So after what period of time? We need to basically solve for t. So what could we do? Have a think of what we could do. That's right. We could make the two equations, set them equal to each other. Is one thing we could do. And solve for t. So remember, here is the vector equation of the pleasure boat. Here is the vector equation of the cargo ship. We're setting them equal to each other, and we're going to solve. So therefore, you can go 10t equals 12 minus 4t, and you can also go 7t equals 12 minus t. So I've got two equations that we can use to solve for t. Use whichever one you want, and then use the other one to check maybe. So if 7t equals 12 plus t, subtract t from both sides, you get 6t equals 12. So t equals 12 divided by 6, so t equals 2. Double check that. 10 times 2 is 20. 12 minus 8, 12 plus 8 is 20. So you've got time equals 2 hours. Because I think there must have been somewhere where it talked about it being hours. So now let's try an IB kind of question. So you've seen similar ones in past exams before. So in a Bermuda context, so you know the Bermudian. Let's say the Bermudian moves with constant velocity along a straight line. Its velocity vector is given by v equals 86. At time t equals 0, the Bermudian is at this point. So here's a point, position vector, and here's a velocity or a direction vector. Find the magnitude of v. That's dead easy. Plug it into Pythagoras' equation to get square root of 100, and you get 10. To find the coordinates of the Bermudian when t equals 5, feel free to pause at any point and try this yourself too. Find the coordinates of the Bermudian when t equals 5 using the general form of the vector equation. Alternatively, you can use this version, which is in the formula booklet, where p is the point 43 or negative 3, and q minus p, remember, is normally the velocity vector. As I think on one of my intro slides for this lesson, I mentioned that the direction vector is often the velocity vector. So how can we write that? So put in the position vector for the point where it's located, position vector here, and t is 5, so sub in t is 5 according to the question, and plug in your direction vector, which is the velocity vector. So doing this, you get 4 plus 5 times 8, negative 3 plus 5 times 6. So there you go. So here's the position vector, and therefore that is the coordinate 44 and 27. So that's why they're asking for the coordinates. Find out what the position vector is at t equals 5 of the boat, because that's where it was initially. After time, it's travelled this distance, so this is where it is now. So that as a coordinate would be 44, 27. Write down a vector equation representing the position of the Bermudian, giving your answer in the form of r equals a plus 2b, the same as that version there. So that's pretty easy. Basically, we've kind of done it there. So we've got the position of the vector at time 0. So this is the position of the vector at time equals 0. And then after time, it moves these distances. So t loops up in the time, and that's the velocity vector. Make sure, some people by accident just write this bit, so that's pretty common. So make sure if they're asking for a vector equation, don't just write this, because this is an expression. To have an equation, you've got to have something either side of an equal sign. So you must include the r equals, or you definitely will lose a mark. So if you're asking for a vector equation, don't be lazy, make sure you write the r equals. Let's try another IP style question. A particle is moving with constant velocity along line L. Its initial position is 3, 1, negative 7, so it's a 3D kind of coordinate. After 1 second, the particle has moved to, so after t equals 1, particle has moved to this position. So find the velocity vector AB. So obviously if it's moved from here to here in 1 second, we can work out its speed per second, the distance it travels per second, by working out the distance between those two. So basically you can do this one minus this one. So written as column vectors, it's a bit easier. So I would have written this one first, minus that 1 second. So in a way you can swap them around. You can write 5, negative 2, 11, minus 3, 1, negative 7, rather than doing negative that plus that. And then work it out, you get this. So obviously it moves this distance per second. So that's its speed, that's its velocity per second. Find the speed of the particle. To do this, remember speed is the magnitude of the velocity vector. So just find the magnitude of the velocity vector using Pythagoras, blah, 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 and you get that. Write down an equation of the line L. So use the general form of the vector equation. Use that form if you prefer, because that's the one you get in the formula booklet. So P is the point at time 0. So remember, P is the point at time 0 because that's its initial position. So the position vector of that point at time 0 is this one here, plus t for time, and velocity vector goes here. So that's easy. Please remember, you must include r equals or you lose a mark. Now let's try one more IB style question. So Queen Latifah's scooter moves in a straight line starting at point A, 0, 7. So we've got our initial point, so it's going to be used in the vector equation later on. Its position P after its position T seconds after it starts, so instead of T we're going to have P, is given by the vector equation. So here's its initial point, 0, 7, plus P, here's the velocity vector. Find the position vector of the scooter after 3 seconds. So all you have to do is sub in 3 into here. So show that you subbed in 3. So then you've got 0 plus 3 times 6, 7 plus 3 times negative 1. Work that out. And they want it as a vector. They don't want it as a coordinate. So if they want it as a coordinate, you'll just write 18, 4 in brackets. If they want it as a position vector, leave it as a vector. And so that's Queen Latifah's scooter. Bradley Cooper's scooter moves in a straight line starting at B, 10, 0. So its position Q seconds after it starts is given by this one. So here's its velocity vector, here's its initial position, and its Q is used instead of T. Both Queen Latifah's and Bradley Cooper's scooters collide after Q seconds, so both scooters collide at the entrance to Walmart car park. Find the value of P and the value of Q when the collision occurs. So when they collide, they're basically equal to each other. So what you can do is you can kind of set them, to do this, set both position vectors equal to each other. So we can go like this. So Queen Latifah's position vector is basically, see, it's 0 plus 6p, 7 minus 1p, that's where this comes from. Bradley Cooper's is 10 plus 2q, 0 plus 5q. So we're just not bothering to write the 0 plus, but it's fine if you do. So you set this equal to this, and this equal to this, and solve. 6p equals 10 plus 2q, and 7 minus p equals 5q. And so you can therefore go, I probably need to show some more things. So what's going on here? So 7 minus p, that's a really easy one to solve, or to rearrange. P equals 7, so add p over here, bring 5q over here, p equals 7 minus 5q, or actually you can also solve from this one, 6p equals 10 plus 2q, and so on. Just 1 second. And see 10 plus 2q I've used again down here. 6p I've instead replaced the p with this version. I'm trying to replace p with the equation for q. We're using simultaneous equations and substitution. So I've substituted p equals 7 minus 5q into here. So times this by 6, you get 42 minus 30q. So 42 minus 30q equals that. Then you can solve for q. So you can subtract 10, you can add 30, and then you get this, and then solve for q, you get q equals 1. Sub q into here, 7 minus 5q, 7 minus 5 times 1, so p equals 2. So I found the value of p and q when both of their scooters collide. And then back to here onto the last bit. Find the coordinates of the Walmart car park entrance. So basically, where is the position when they collided? So to do this, sub in p equals 2 and q equals 1 into the two position vectors. So here's Queen Latifah's. You can sub, hers has p, so sub p equals 2 into hers, and you've got 12, 5. You've also got Bradley Cooper's position vector, sub p's q equals 1 into there. Just to confirm, you've got 12 and 5. So see, you had two ways of getting the answer. Therefore, that's the position vector of the Walmart car park entrance. But this, and they wanted it as coordinates, so to write it as coordinates, you'd write it as 12, 5. Okay, hope that was entertaining, and thank you.